Okay, so let's review Unit 3. This has been a big unit. There's a lot of material, and you are going to need to actually study for this to prepare. So get a notebook out, get some paper, a calculator, a handheld calculator. Remember, you won't be allowed to use Desmos, so make sure you have a handheld calculator. You can use your phone from home to practice, and you won't be able to use your phone for the test, but you can use a handheld calculator during the actual test. So grab that if you need it. Pause the video and let's establish something here. So to adequately prepare for a major test, and I would consider your solving quadratics a major test, it is reasonable to spend at least an hour studying. Now I want you to think about that. You know, how many days of class have we had? How long has each class been? How important is the test? So to say you should take between 4 and 5 in one afternoon to prepare for a major test. That is a reasonable amount of time. Okay. Now, this review is going to be structured as a practice and then review. That's going to really be up to you. But what I want you to do with each problem set is pause the video and you try to do the problems on your own as though you were taking the test. Do your best, have your notebook out, work through them, and then unpause the video and we will go look at them together and you can kind of grade yourself. So I want you to treat this review like it was a practice test. It mimics the actual test. And so it'd be really good to do that. Now, as you're starting the video right now, note the time that you are starting. Is it like right now when I'm recording, it's 4:04, almost 4:05 in the afternoon. Okay. Maybe it's, 5 o'clock, 10 o'clock. I hope it's not 3 in the morning. Okay. Like, I really don't want you doing this at 3 in the morning, but note the time that you're starting and keep a record of how much time you spend total, even if you review in multiple sessions. So, like when you're done with this, note the time you stopped and then keep track of how long you were actually studying, including your practice work and the time that you're watching the video. And if you're doing it in multiple sessions, make sure you add up all of them. So you might do 20 minutes now, 40 minutes later, something like that. Okay. So make sure that you are keeping track of the time. Now, one of the skills on your test is going to be algebra tiles. And there are 2 questions that will be on the algebra tiles. And you're going to have different figures, but take a look at this one. What are the dimensions of the figure below? And what would this look like as a generic area model? So pause the video and jot down what you think the answers to that would be if you were to just see that on the test and then unpause it. All right, so to answer the first question, what are the dimensions? What you're doing is you're kind of looking, well, we're going to do this, I guess, for both. We're looking at this, and we are seeing that across the top, we have 4 x's, and then we have the 3, and then going down the side, we have x, and then we have minus 2. So the dimensions would be 4x plus 3 times x minus 2. So that's what the answer would look like. On your test, you're going to see a figure that looks like that, and then a line off to the side, and that's the kind of thing you write on the line. Now, the second question is, what would this look like as a generic area model? And for that, you would have your boxes set up, and inside you would have 4x squared, 3x's, 2, 4, 6, 8, negative 8x's, and negative 6. So you're translating that into a generic area model. So that's what those 2 look like. That constitutes the first 2 questions on your test. They should not take you much time at all. Okay, not much time at all. Now, for factoring, there's a lot of factoring. So we have GCF, greatest common factor, difference of squares, trinomials and combo ones, like ones where you have like a GCF and then you have to factor something. There are 5 such problems on your test. These ones are similar to the 5 problems that you would see. So go ahead, pause the video, and try to work all 5 of these as though you were working on the test. So you want to keep like the radio off. You're not checking your phone. You are going to work through these. And then when you think you have done everything you can do, unpause the video. Okay, now I'm going to work these one at a time in the space that I have, and I'm going to erase in between. So at any point, if you need to pause the video to jot down some work, go ahead and do that. So for this first one, we always want to train ourselves to look for a GCF. You do not have to do the prime factorization on this, but you can. So when we did this in class, we did what's called prime factorization, and we factored everything as much as we could. So we factored the numbers as much as we could, we factored the variables, and then we go through and look and see what they have in common. So we have a 2 in common, we have an x in common. So the GCF is 2x, and then everything you're left with, so I'm left with 2x, a minus sign, and a 3. That is what I'm left with. So factoring out the GCF on that one is 2x times 2x minus 3. Moving on to the second one. And again, at any point, if you need to pause the video. I don't know what integrated camera was. Is that like my face down at the bottom? I don't know. Pause the video, rewind it to go look at something more closely. Go ahead and do that. So on this one, we have 25x squared minus 36. And what you want to notice about this one is it is the difference of squares. So 25 is a perfect square, x squared is a perfect square, and 36 is a perfect square. And they are a difference because we are subtracting. Difference of squares will factor into conjugates, where you have one's a plus and one's a minus, and then you pretty much ask yourself, what's the square root of all this stuff? So what's the square root of 25? Well, that's 5. Or you could say, what times itself gives me 25? X times itself gives me 5x there, and then, or x and x, and 36 is 6 squared, and so we take the square root of that. And so we end up with a 5x plus 6, 5x minus 6. That problem should not take you long at all. That problem should be in the vicinity of 10 to 30 seconds, depending on how long it takes for you to process that you're looking at the difference of squares. But there's no work for you to show on that problem. Now, once you get to the trinomials, you are going to be expected to use the area model. Some of you have a bunch of notes in focus because you are turning in work that is not done using the area model. And I keep saying over and over again, you are going to have to use the area model to do this factoring. And in fact, it says on your test, if you do not use the area model, the maximum amount that you are going to be able to get on those problems is 1/3 of the points. That's a 33%. That is not what you're aiming for. So, and the reason I do that is not because I'm trying to be a jerk to you guys. It's because cheating is so rampant, and most of the online helps do not do this. And using the area model is one way that I can be more sure, not certain, but more certain that you are doing the work yourself. So looking at this one here, we've got x squared, we've got a negative 14, and then we do the a times c to get negative 14, and we're going to find 2 factors of negative 14 that add up to negative 5. I've got 1 times 14, I've got 2 times 7, and that's all I've got, but thankfully that's all I need. 2 and 7, if I subtract them, I would get a 5. Now I have to get a negative 5 out of it, so it would have to go to minus 7, or in other words, the 7 would have to be negative. And so I'm going to go put in the 2x and the negative 7x, and then we can GCF factor this. I'm going to go this direction. What is my greatest common factor between x squared and 2x? And the answer to that is x. x times x is x squared, x times 2 is 2x, and x times -7 is -7x, and -7 times 2 is -14. So this factors into x plus 2, x minus 7. There we go. Okay, again, pause the video if you need to grab that work. And let's look at the next one. Okay, next one we have 3x squared minus x minus 2. And just remember that that is -1x right there. So when you see the negative x, that is -1x. So we're going to do 3 times -2. And we are going to get -6. I put my little lines in the wrong spot there. And 6 factors into 1 times 6 and 2 times 3. 2 and 3 is the only way to get a -1 if you were to do 2 minus 3. So we want to make sure that the 3 is negative. So we'll do 2x and -3x. And I am going to factor in this direction here because I want to avoid that negative if I can. Greatest common factor between 3x squared and 2x is x. And x times 3x would give me the 3x squared. X times 2 is 2x, and 3x times -1 is what we would need to get the -3x. So my factors are 3x plus 2 and x minus 1. Alrighty. And last but not least on this, this is a combo one. If you look at those numbers, they are big. They're bigger than we want. They're not really what we're looking for there. And so that might be a tip off that yes, there is a common factor that we could get out. And you might want to start by looking at whatever that number is out front. See if that is the common factor. That would be good. If not, you go with something a little bit smaller, like say a 2. But it turns out that 4 is the common factor here. So we're going to go ahead and factor out the 4. 4x squared, factor out of 4 gives me x squared. 24 divided by 4 is 6. Or you could say 4 times what gives me 32? That would be 8. And I'm going to set up my area model off to the side here. Okay, and we have 1 times 8 is 8. And we are looking for 2 factors of 8 that add up to 6. Well, my candidates are 1 times 8 and 2 times 4. 2 and 4 is the combination that adds up to 6. Greatest common factor between x squared and 2x is x. X times x is x squared. We get a 2, we get a 4. 4 times 2 is 8. And so my full factorization is 4 times x plus 2 times x plus 4. Not too bad. It took me a little over 8 minutes. Actually, I don't think it took me that long to do it. 8 minutes to do that. So probably took you quite a bit longer to do it, and that's okay. All right. Remember, you're keeping track of your time on this. All right, on to the next skill. So we also covered in this unit complex numbers. And so you are going to have to operate. You're going to have to add, subtract, and multiply with complex numbers. Please take a moment and note the operation. Most common mistake that results in no points is when students see parentheses and just jump to, I see parentheses, therefore I must multiply. No, like only multiply if it's multiplication. So in this first one, it is just adding. And so I am going to remove the parentheses and then combine like terms. So we're going to do 2 minus 4, which is -2, and then 3i plus 5i, which is 8i. Your adding problems should not take you much time at all. Okay, your adding problems should take you less than 30 seconds to do, certainly less than a minute. So they're going to be some of the faster ones that you do. You're just combining. You don't have to worry about signs really. Okay. Now my next one here is a multiplication problem. And so what I'm going to do is set this up with the area model. Okay. So we're going to go ahead and do this in the forward direction. And 4 times 4 is 49. 7 times negative 5i is negative 35i. 7 times 5i is positive 35i. And we remember that that happens because these are conjugates. And when you multiply conjugates, the middle part drops out. And then 5i times negative 5i is negative 25i squared. So when I go to add this, I get 49 minus 35i plus 35i minus 25. Now, critical thing here, I squared is equal to negative 1. Okay, I'm going to star that. You've got to know that. So over here, instead of saying 25i squared, I'm going to say 25 times negative 1. Negative 35i and 35i cancel each other out, and 25 times negative 1, or negative 25 times negative 1 is positive 25. And then what on earth is that? 49 plus 25 is 74. And there we go. So the answer to that problem is 74. And we definitely want to remember that I squared is equal to negative 1. Again, I'm going to remind you, pause the video if you need to like grab this work and review it in further detail. Okay. And I don't know if I said it at the beginning of this slide, but you should have paused it and worked the problems on your own. If you didn't, pause it right now and do the last 2 problems. So you got a little bit of a review, and then pause it right now to work the other 2. Alrighty. Okay, now the next one is a subtraction problem. And the most common mistake that's made in subtraction problems is not distributing the subtraction or not subtracting everything. So we've got 3 plus 5i minus 7, and then what's happening here is that subtraction is getting distributed. So it's minus 7, but then it's also minus negative 2i. Now, I don't normally write that. I would not normally have done that. Minus negative 2i is the same as plus 2i, but that is the most common mistake that is made in a subtraction problem, is failure to distribute the negative. Once you do that, it is just like an adding problem. So we have 3 minus 7 is negative 4, and 5i plus 2i is 7i. All right, last one. Last one is another multiplication problem, and this one is not conjugates, so like it won't drop out. We will get a complex number as an answer. So we have 3 plus 5i times 2 plus 3i, and I'm going to go ahead and set up my area model. So 3 plus 5i, 2 plus 3i. 2 times 3 is 6. 2 times 5i is 10i. 3 times 3i is 9i. And 5i times 3i is 15i squared. Do make sure that you're getting an I squared when you are multiplying I times I. Okay, it's not I times I is I. No. All right, now we're going to combine all of these. So we have 6 plus 10i plus 9i plus 15. And once again, I'm just going to remind you, I squared is equal to negative 1. So instead of writing 15i squared, I'm going to do 15 times negative 1. Combining these two in the middle, 10i plus 9i is 19i. And 15 times negative 1 is minus 15. And 6 minus 15 is negative 9. So we get negative 9 plus 19i, and you should leave it in a plus bi form, meaning your complex, your imaginary number should be after your real number. So it should be real number plus or minus the complex number. And there's your operations with complex numbers. As we're going through this, make a note on which ones seem easy, which ones seem hard, what do you want to start with, and so forth. Now, for this last one, solving quadratic equations. Now, you are going to see 4 problems. We're going to practice with 3 of them, but there are 4. One of them you must solve using square roots. One of them you must solve using the quadratic formula, and one of them you must solve by factoring. And I will tell you this, since you're watching the video, one of them must be solved with the quadratic formula. The quadratic formula will be on your test. But you won't be able to factor it. And one of them, there's another one that can't be done by factoring, okay? And that is best done by square root. So, okay, so pause the video, work out these 3 problems, and then unpause it, and we'll talk about them. Okay, so if you have to solve one by a square root, which you do, the thing you want to remember is that the b value has to equal 0. So it'll look something like ax squared plus c equals 0, or like ax squared plus c equals some kind of constant. In other words, there's no x by itself, like that's not a thing. And so if I have to solve one by square rooting, I've got to pick that first one. That first one has to be the one that I solve by square rooting. So let's go ahead and do that. So we will subtract 16 from both sides. So 4x squared equals negative 16. Divide both sides by 4. We get x squared equals negative 4. And then recall this, when you go to take the square root, okay, so we're going to undo the squaring with the square root. We have to add that plus minus. You know what? I'm even going to do it in a different color just to make it stand out. Must have a plus minus. Some of you guys argued with me about that. Now, here it gets a little weird. Now, the square root of negative 4, you might know, well, the square root of 4 is 2. And the moment you see that negative under the square root, you know you've got an I going on there. So it's plus or minus 2i. Now, if you're like, wait a minute, how did she get that? I don't remember doing that. Here's the reasoning behind it. It's the square root of negative 4, we split that into 4 times negative 1. So it's the square root of 4 times the square root of negative 1. The square root of 4 is 2, and the square root of negative 1 is I. And so that is your like other way of thinking of I is the square root of negative 1. So I squared equals negative 1, and I equals the square root of negative 1. I'll put those both up there like, one. Okay, so you can see that they're not the same statement. So we have I equals the square root of negative 1 and I squared equals negative 1. That they're the same thing written 2 different ways. Okay, but like you don't want to say I squared equals 1 or something like that, or I equals negative 1, because it's like not the same. I squared is negative 1. Okay, now this second one, what you could do if you want it, well, you know what, it doesn't matter how we're going to do it. We're going to start it the same way. So we have x squared plus 2 equals 5x. And whether we're going to use the quadratic formula or factoring, we still have to get a 0 either way. So I'm going to go ahead and subtract 5x. And make sure when you're rewriting it that you tuck that negative 5x into the middle so that it is in the what we call standard form. Now, what you could do, you could start doing this by factoring, okay? And so you might start by saying x squared and 2, and then you do 1 times 2 to get 2, and you're looking for 2 factors of 2 that add up to negative 5, and you kind of quickly realize there aren't any, okay? So this is an example of one that is not factorable, and I'm telling you in advance that you will see one that is not factorable that you have to use the quadratic formula on. And so when you see that, you don't need to spend more time staring at it, wondering what on earth is going wrong. So we're going to go ahead and use the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. My a value is 1, my b value is negative 5, and my c value is 2. So let's go do this. The opposite of b is -5, and the opposite of -5 is 5. Plus or minus the square root of -5 squared minus 4 times 1 times 2 all over 2 times 1. -5 squared is 25. 4 times 1 times 2 is 8. And 25 minus 8 is 17. And you cannot take the square root of 17, and so you are done. And you can, man, it really looks like it's going to rain. I still have to go for a run when I get home. Okay, so you can see that that does not simplify. And when I wrote this review, I really tried to write this review so that it mimicked the level and depth that you would see on the test. Okay, so there's our square root one. And that means this last one must be our factoring one. And as with the square root or quadratic formula one, we have to get it equal to 0. So I'm going to go ahead and add 6x to both sides and then subtract the 27. So we have x squared plus 6x minus 27 equals 0. And here are my factors. And I'm going to come over here and set up my area model. So I have x squared, I have -27. I'm going to do 1 times -27 to get -27. Sorry about my handwriting up there. And what factors do we have at 27? Well, 1 times 27, that does not get me a 6. 2 doesn't work because it's an odd number, but 3 does. I get 3 times 9. 4 won't work because 2 doesn't. 5 doesn't work because it doesn't end in 0 or 5. 6 does not work because 2 doesn't. 7 and then 8. Okay, so we got them all. And the one that's going to give us the 6 is that if the 3 is negative and the 9 is positive. So we'll put in -3x and 9x. GCF between x squared and -3x is x. X times x is x squared. This is -3. This is 9. Double check that -27. Yep, that works. And so I get x minus 3, x plus 9. And you are welcome to go straight to x must be equal to 3 or x is -9. If you need to see what the work is for that, it is x minus 3 equals 0, and then you would add 3 to both sides. This would be x plus 9 equals 0, and you would subtract 9 from both sides. Okay, so that all took me 27 minutes. The timer running on this video is coming up on 28 minutes. And that was with a couple of minutes of lead in, as well as some like introduction of the types of problems that you'll see. Yes, the quadratic formula will be given to you on the test. And you'll have one more factoring problem. So basically, we went through a practice version of the test minus one factoring problem. Okay, everything is of comparable difficulty. So here's the deal with watching the video all the way to the end. I have a finite number of bonus points to award. So I've got 2 thresholds, and how many we work with depends on how many people do it, because I'm not going to give you like 30 bonus points on your test. Like that would not be good teaching. But there's a finite number, meaning, well, here's the deal. You're going to divide the points equally among the other people in your class who have done the review, or no, total, not just in your class. Total, it's across all 3 classes, okay? So you are going to tally up how many minutes you spent on this review, okay? This video is going to top out probably right around 31, 32 minutes. So you can include that. And I want you to go and back at the beginning. How much time total did you spend reviewing? Now, there is no minimum amount of time. So if you did all of the problems and they only took you 10 minutes, then fine. If all you did was watch the video, then put that number in, okay? I spent 32 minutes, then I know you only watched the video, but that's your choice, okay? You're going to go onto Teams. You're going to go to questions and discussions. Please go to questions and discussions. Do not copy, like put this on the Teams post for this video. And you're just going to put in the number. Okay. So if you spent 45 minutes studying, if you spent 90 minutes studying, now it's pouring rain. You're going to just put the number. That's going to be the only thing that you put in. On test day, I'm going to tally up how many people total did it. Now for 8A and B day, that's going to be a little bit awkward. So 8A people, you're going to have to wait until B day people take their test. Okay. But you will get your points. All right. I promise. After we see how many people comment, I'm going to take the points. I'm going to divide them equally among all the people that have commented, and then you will get that many bonus points on your test. So now the twist to this is that it's to your advantage if your friends don't watch the review video. So don't tell them what the secret is. Okay, now your friends have the same opportunity as you to watch the video all the way to the end. They need to do it on their own. If they do it on their own and they post and they get in on the points, fair enough. But it is not in your interest to tell them, hey, you need to do this and you need to post a number, because what it means is they're going to take some of your bonus points away and they're not going to have done the review. And how is that fair? That's not fair. Okay, so keep that in mind. Be prepared for questions on our review day. Well, I guess we can't do that because of when I'm recording it, but yeah, so I don't know, email me if you've got questions and I'll see you on test day.